Thanks for that. Just I made a little note demo. I'll just go through everything step by step and explain what everything does. So should I explain UCAN as well, or?
I think everybody will have been like at least tried to bang their head against the code a little bit.
Okay.
But yeah, I mean, what's important is tying this back to things that are really happening. So that kind of explains UCAN as you go.
Okay. So let's see. So there's a JavaScript file in the demo folder, and that's like a representation how you would implement like a connector. So you have your Cloudflare hosts, and then this is your DID from the server. Ideally, we would avoid using the private key except anywhere else on the server, and just use the public key in the client.
You mean if we treat that did properly, it's going to be like a cloud managed resource that's maybe non-extractable or whatever?
Exactly. So from there, I try to use the Web3 storage stuff as much as possible. So I was able to partially reuse their CLI or their JavaScript client library. So that's what I'm doing here. And it's basically just saying, hey, connect to this Cloudflare server we're set up over HTTP, and that's it. And from there, we're getting straight into the Merkle clock stuff. So I made this client file, and that's basically methods that should be implemented on the connector. And people can just almost copy this. So that should save us a bit of work for in the future. And it also shows like what the exact steps are that you should be implement in the flow. So we create a clock, then we register it, and the registration is actually not technically necessary, but we have to get the UCAN that we create in the first step on the server, so we have access to it later. And that's all the registration does.
Okay, so basically the clock itself, once it's created, it's, I guess, is it the audience? So the clock is owned by persona, basically.
Yeah.
And so the clock then, if you had some other way besides registering the clock and some other way to resource manage the clock updates besides the cloud, you wouldn't even have to register the clock. You could send the clock around to other peers and they could append to it if they had the valid UCAN for that. I think even without going through a cloud, that's the point of doing it all with crypto.
Yeah. It's also represented like that in the tests, I hope. Because I made like a distinction between offline and using the server. And then you can like basically reconstruct the flow looking at these specs. So here they start with just creating the clock. And in all these specs, there's no server involved. And then when you look at the other file, it's basically the clock creation and then the additional steps you have to take with the server.
Okay.
But yeah, back to the demo. So that makes sense, the registration, why it's necessary.
Remind me that I'll want to come back. Yeah, I mean, I guess the registration is necessary for our user flows. Let's say the registration is convenient.
Yeah.
When we're done, I want to come back and talk about what it would mean to have it not be a clock or whatever, or have our server implement something other than W3 clock. And so maybe change it to a different UCAN capability name or something, but we can come back to that. So
All right, sounds good. So after we've done that, or before we do that, doesn't really matter. We have to log in using the WebT storage client we're reusing. And that's basically getting a few UCANs from the server to like verify that our email is actually an email and not just some fake account. And that gives us a few UCANs. That's the agent we're representing here with 2 UCANs. There's a delegation. That's basically saying my email, the account, is delegating everything to this agent, this client, and then the attestation is a verification that the email is valid.
can we go back and look at that again? I just want to make sure it's clear. So, because interesting to me, you're just creating a static. You're like assigning an object to the client there, like you're mutating the client, which is cool. But just to be clear, what's happening? The account agent issuer is the principal on this agent, I guess, and then that. So that's like going to be. Well, okay, so where in there, I guess, so the agent is the device? Is that?
Yeah.
Okay, and so where does the device, like, is that what the line 82 is?
The signer is the principal. Yeah, that's the same thing.
Okay, so that's the device. That's like the non-extractable device key.
Yeah, exactly.
Right on, and then basically the client, which is a thing in client TS, picks up that dot agent object and is able to combine the attestation, the delegation, and the issuer, the ability to do the signing, into enough muscle to get things invoked and to get things invocations created and sent or whatever.
Yeah, we
That's
have
cool.
to pass
Okay.
this attestation and delegation in other UCANs as proofs that our agent has all the capabilities that it needs.
I like this style because it makes it really clear what is going into the client as far as like a function, right? Because otherwise that rich client can be kind of hard to tell what all the state is that matters. So I like this.
Cool. So here next we create our first clock event. The clock advancement. There's a clock event creation function in the client that you can copy.
Can we pop in there real quick? I'm kind of
Sure.
okay. So that's gonna like, got it. Okay. And is that like working off the W3 clock wire protocol?
Yeah, this is the exact format to use in the spec. This can be anything, the event data itself.
Right on. Okay. Well, that's cool. That's pretty close to what we do anyway. Thanks for popping in there. I guess maybe we can go back to the main one.
Yep, and then we have to store the event on our Cloudflare server. That's what happens here.
Okay.
Well, we first invoke the capability to store, and then here next we actually store it using Cloudflare R2.
Mm-hmm.
Then after that, we use the event in the advanced clock invocation. That's what happens here. Do you want me to go like in every one of them to like closer inspect what happens?
Oh no, but this is cool. The clock caps, is that like again kind of similar to that set of state that we saw for the agent client, the client agent? What is clock caps? Or is that oh, that's off the yeah, I want to see that. Cool.
These are custom capabilities that are wrote for the clock stuff. So
So this
for
would be
the
like where we might modify on the other end of our client if we're moving away from W3 clock.
if you want to change the data format of their capability format, yeah, that would be here.
Cool. All right. This looks
So we
great.
don't have any other capabilities because we're just reusing everything from Raptor storage.
Mm-hmm. And then the store ad that you used for storing that event just stores. Okay, so the store ad that you use for storing that event stores car files that are meant to be unencrypted and then unwrapped and accessed by the clock service while it's at runtime.
Yeah, exactly.
And so the clock service also has the ability to post like if you know what the clock service is gonna IO to, like if you know the CIDs it's gonna need before you invoke it, then you can put those as blocks on the like NB object for the UCAN, I guess.
Mm-hmm.
And that's how I've done it in the past, because then we don't have to like wait for the clock to synchronize with its backend storage. We've already done all the IO, and so we spend less time with a network connection open.
Yeah.
Even though we send more over it.
Mm-hmm.
And so it would be cool to see that, but also that sidesteps some of the encryption not really, right? Like you store it or you don't, but the main thing that we'll have that maybe we'll get to in a second is when we put an encrypted car file. I think what we want to do, I mean, I forget how they disaggregate. So like on the Web3 storage API, there's upload this car file to where I could get just it back versus upload this car file and crack it open into individual CIDs that are advertised in the car file header, and put those on the content delivery network. And that second thing we don't need. I mean, we'll end up doing a custom thing where you upload the car file and the car file itself goes on the CDN. And so we might do a variant there. So maybe it's worth, as we get back into the next, back here into the flow, just to like call out where that would happen.
So the car file upload, I just think we have the basic one. So we construct the car file itself on the client. And nothing special happens. We upload the bytes from the car file and that's it.
And then those are just in R2 for now. That's great.
Yeah.
I mean, so our store ad just doesn't do all the fancy business. And then the W3 clock is accessing those not by IPFS CID, but by grabbing the car file, or
Yeah. So when we advance the clock, the Cloudflare server retrieves the event and verifies that it's an actual event with the correct data format, and it gets that straight from R2.
Okay, yeah. Let's come back to that because that looks like an interesting detail, but I don't want to derail.
Sure. Then it's basically the same flow to get the head of the clock, and there's not much other capabilities besides that. And after that, we get in the sharing flow.
And so to get the head of the clock, if you don't have, like by default, it's owner only? I have to grant you the get access, or I wonder, is there a way to make one world readable? Is that easy? Have you noticed?
World readable. That's a good question. I guess you could add it to DNS or something.
Oh yeah, I don't mean like the name easy to discover. I mean like if I don't have any special capabilities, can I run get clockhead?
No, we can make it just without the UCAN, yeah, public, yeah, for sure.
Mm-hmm. Okay. Well, all right. So now this is the interesting part. I guess tell us about how the share works.
So the share works. Yeah, where do we start explaining this? So we create a delegation from one email address to another, and we give it a proof from the original delegation we made from that temporary key pair to the email address we saw in the beginning in the create step.
Wait, so the Genesis clock delegation is what you're calling the chain that says like say I'm J Chris and I'm sharing to Bob. Genesis clock delegation says J Chris's device agent has ability to do stuff to this clock, and that's what I end up delegating.
No, the Genesis one is the one we did in the beginning, the create one. Let's see, where is it here? Oh, here. So that's the one that has this temporary key pair that we throw away afterwards. And the audience is the email address. That's a Genesis delegation.
Oh, I see. Okay, so that's the one that says the principal associated with like the current session can do things on the clock, and then we're delegating from that. That's awesome.
So that happens totally offline. And the next thing we can do to like work offline is like verify that Alice actually exists. And it's not just like a man in the middle attack or something. And that's this process here. And for that we need like those agents delegations and attestations from both persons.
So just to understand that, that's like the attestations from the server is just how in our application we've chosen to believe that the other principal is associated with Bob at example.com or whatever.
Yeah. So whenever you like log in or go to the share flow to like verify everything with the server, you get an email. And when you click in on the email link, the server creates an attestation, and that basically verifies that the email address is valid. And so you can associate with it is valid as well.
So that attestation then is the thing that's like encoded in the email that we send out, and basically then when so we send an email. I think this is what W3 storage did or does, is you click the link in the email and it brings up a page with that delegation kind of ready for you to execute, and then you just press the button that makes it go.
Yeah, exactly. I reused those components from Repli storage.
And so what we'll do, and this is like worth noting, this is our extension point. We'll do that, but after we'll do that automatically, and then we'll do some other stuff automatically that'll culminate in whatever your source data is page, like syncing live on the landing page that you just got to. But that's kind of where that flow will kick off from, I think.
Mm-hmm.
It's like instead of automatically instead of there being a link you click to send that delegation, there'll just be like a bunch of cranks that turn until you get your data.
Yep. So yeah, you can verify everything offline. But to use the actual clock capabilities, we have to go to the server flow, and that starts with this authorize. This whole flow is like based on the email flow, so it's very similar, but not quite. So it's like you'll see the same capability names when you look at the access capabilities from Web2 storage. So you can kind of compare them.
Can I see if I understand this? Like, we are kind of just needing some kind of bulletin board to share information to Bob so that he can mess with the clock that Alice shared with him or something, and with the server that controls the clock. But
Mm-hmm.
yeah, I guess if they were connected, okay, so like it goes through an email right now, but like let's say Alice and Bob were both live in the application. Could we and we had like and the server was already authorized onto, one of those connections with them? Could we broadcast it? Could it like pop up as a toast in the dashboard or happen automatically on the application developer could code it into their flow to happen automatically, or does it have to come through the email click?
I think we can skip a few things, but for Bob to like be able to invoke all capabilities, I think we need to go to the email flow.
Like, I guess maybe it's not like, we could sub out email for some other opportunity the server gets to sign something? Like, could it go through some API, like a server WebSocket?
Yeah, probably. That's a good idea.
Okay, that's worth thinking about because once they've established that they trust the server for that session, we should take advantage of it to make things easier for them.
Mm-hmm.
But all right, so I think I understand what's going on there.
Yeah, so the first step in that email flow is to like for Alice to invoke the email. So he or she gets an email and then clicks the link, and meanwhile Bob is trying to claim the capabilities from Alice and just basically polls until Alice has clicked the link in the email. And when that is finished, Bob has the proof that the share is valid, and then they can invoke the advance and clock head capabilities themselves, and the database is shared effectively.
That's great. Yeah, that makes a ton of sense. That's cool that you got it all into one file for the main path.
So yeah, you can see here in the demo, I was waiting until Alice clicked the thing. Then it confirmed, got the delegation, and then I invoked the head capability as Bob.
Mm-hmm.
And that's it.
Now, when you're running this,
That's
is
cool.
this running against Cloudflare or is this running against a local server?
It's Cloudflare, yeah. I couldn't get it to work locally because the only thing that doesn't work offline is the Cloudflare R2 upload. So
Right.
you have like a local R2 store, but you can't talk to it through like a URL or something.
Okay. Do we have shared credentials, Chris, that we can use, or do we just need to each set up something? Or obviously, one of the first things I would want to do is try and repeat this and just,
Let me add you to the Cloudflare account. I can do that real right away.
Yeah, and I have some credentials in my 1Password I can share with people. Is there anything else you want me to go through, like other specs or something?
Yeah, it'd be cool to see the repository layout, and like point out, I don't know, stuff that, especially loose ends or places where there's more to be done.
So the only issue with this whole flow is that I had to like hack in that UCAN :* functionality, but the WebT storage folks didn't code. And there's only one problem with it, which is if you have too many UCANs in the proofs, it like fails. So if you create like more than 5 clocks, it just goes up in fire for some reason.
Interesting.
Yeah.
Well, okay, so maybe just because I don't want to keep people over too long, but thanks for showing us everything. Next steps, maybe, do you think this is essentially ready for somebody with like another one of the UCAN experts to review it? We've got a bunch of friends in that community, and so they could take a look, and maybe it'd be best if you showed them, because you could get into the stuff about the patches on UCanto or whatever.
Yeah. Unless we go to the party kit route, make a whole new server and switch to another UCAN version.
Well, if we go this party kit route, I think what we do is we just hoist your code there, like we just kind of get it done style, and make the and change the clock capability to be, like I said, a W3 clock or whatever. Change it to be Fireproof clock and have it use the logic we already have.
Mm-hmm.
And so then it's really, you don't there's a bunch of stuff in what you've showed that has like some concern for like the wire protocol and getting the head thing structured right and whatever. And I guess there's a certain amount of that. I think that I've just been working on these gateways over the weekend, and they're going to fit right into this. So maybe a next step is to work together to build one that uses all this stuff.
Chris, one thing that would help me just to connect the dots would be, I'm sort of like you. I've spent so much time in the gateway recently. I have a sense of like, what are all the entry points to the code from the gateway side? It would be useful to start mapping them and say, Marty, like a get meta operation on the gateway is going to turn to like a clock, advance or something, in this flow, because it feels like all of those pieces have to sort of come together. And I imagine there'll be like whole blocks of it where you sort of like copy and paste and say like, all right, this chunk is going to sort of plug in here. Obviously, it's going to be rough at first, but I think it'd be useful just to start sketching some of that out.
Yeah, that sounds great. I mean, I could do it off the top of my head right now. I don't know if people have patience for it, but the gateways are pretty simple.
Yeah, we're still recording, so I would say, yeah, just dump it out and we can listen to it again.
So your gateway is going to do its setup stuff. It's going to do a get and a put and, like delete and destroy that we can mostly ignore. The get and the put get split by the router in most gateways so that the meta and the data are handled differently. And let's just talk about the data for a second. The data goes through what we saw here as a R2 upload path. And so to write some data, it's just a car file. You go use your UCAN to talk to a service, and the result of the service is a signed upload URL that when you post your data to it, now it's in R2. That URL that it's accessible at in R2 that you just made by uploading it with that process, that's where you go to get it later. And so if we had a gateway for this, it would template that URL, and it would probably look exactly like what we're doing on AWS. So that's the put data and get data flow. And as far as I'm concerned, for launch, the amount of validation we need to do on a UCAN for put data is like, did they try to put a UCAN on it? Like, I don't need them to come like pre-flight their account with us and get some kind of token and cross sign this and that. Like, for putting the data up, it would be cool if we can, DDoS protect ourselves and like attribute stuff to individual clients at some kind of operational level, but like it's not even necessary. And maybe we just at base level need to be able to, pull an emergency lever on a certain remote. But aside from that, the uploading car files doesn't need to be like, they don't need to be tracked by which database they go with or anything. They're just like we just have a big bag of car files for the whole service. And so that makes that easy. Then, so that's put and get meta. Eventually the get meta will probably wrap in a content delivery network, like whatever the Cloudflare on top of R2 normal way is. I don't know if that changes the URLs or not, but that would show up on the get data. So that's all. Yeah. Put data, get data. Now to switch over to the meta side. The thing that we saw here as like fetch the latest clock down there at the bottom of what happened in that story, the demo index. I forget what it's called in UCAN, but that invocation that was the last thing that proved the share confirmed. Yeah, get clock head. That's basically what a get meta is. We'll make a get clock head that returns the head that is right for us. I mean, I think it could have multiple entries, usually just one, but I think that's the same with what's going on here. And so then for putting to meta, that is a thing where we take the current snapshot of the database and we wrap it up just in the same format as the thing we get from get meta, and we put it to the service. And so it's a little bit simpler than advanced clock, because advanced clock is kind of like also asking the service to validate that the history works and stuff. That's really cool because it allows peer-to-peer, but I don't think we try to launch with that because there's more things that can go wrong. I think that's like a post-launch thing to do the clock properly. If the clock, I don't know. Yeah, I think it would just be risky to try and do that right now.
So let me ask a question on that, because maybe this is what you're saying in slightly different words, or maybe it's something else. The gateway right now is kind of like dumb, if you will, right? Like it doesn't know what's in those meta messages. It kind of just like stores them, retrieves them. Just the naming of advanced clock sounds like it's a lot more like knowledgeable about what the metadata is and working with the data structures. So I guess
it's not that dumb. So I had to go in there over the weekend, and now the gateway parses and unparses its stuff to mess with the keys and whatever.
Because that had kind of gone away at one phase of this gateway rewrite, but it sounds like some of that logic is back in the gateway then about like,
I just had to do some stuff. I mean, I did the screencast that's in the channel. It will answer a lot of those questions. But I think for purposes of what we're talking about, advanced.invoke or whatever we see here is just like a fancy way of spelling put meta. And we just have to get the format right. But yeah, the server cares about what's on the other end of put meta, like the Fireproof server's receiver of put meta is its like most complicated part, because it has to be like, hey, is that meta, does it obsolete some of the other meta that's in the clock right now? And if it does, then we clear the old meta out, and so the clock doesn't get too big. And that's why we call them both a clock. And like if we did our thing fully properly, it would be like what the W3 clock does. The W3 clock, if you have it keeps track of deeper history, like it'll go look for lowest common ancestor and whatnot, whereas ours, if we just don't do that, we let the client merge it anyway. It's actually kind of part of the robustness. The client manages all that stuff inside of the encrypted envelope, and so we can just clobber stuff at this layer and have it work safely. And so we have a more coarse-grained clock that we can use for now. But I think that we might even be able to receive this serialization and act coarse-grained on the server side, although I think we can do simpler than that. But yeah, so the put meta goes on the server and maintains a set of current clock entries, right? That it may grow depending on what you send and what other people have sent in the interim. And then get meta is going to return whatever the current members of that set are. So that's the whole API surface area for the necessary stuff. Then there's like some of them you can hook onto a WebSocket that will push meta at you when it happens. And it's self-explanatory what you do with that. You just act like you just got it right now, because it's the same structure as all the other meta you would get if you did get meta. So I think that's it. If somebody listened to all that, then and then watch the screencast that I just put in the channel, they might be like to where they can start reading the code on the connectors, adapters, gateways, and figure out where to drop in.
Yeah, my thought was we might be, I mean, we're still a little ways off, and I know you want to review this independently of the client work, but it feels like we could start like a skeleton of a client that like at least like it can physically talk to the Cloudflare, and you know what I mean? Like start ironing out those issues now. Because
yeah, we can totally write one. I mean, like if so the packaging is I think it's worth it to crank on the packaging for a while, because it's gonna get us, I don't know, there's unknown unknowns in there.
Agreed. We're solving many things in that same space at the same time. But yeah, I was just sort of thinking
but
like
there's no blocker.
Right.
Totally fireproof UCAN like inside of the test suite land. And it's like it's a comfortable space in there when you get the test suite targeted at your environment and you have like a hello world file and you're starting to implement your put and your get. And so yeah, it's ripe for writing that new client. There's no blockers at all for that.
Okay, thank you.
So Stephen, if you wanted to get into that would be amazing. I won't be able to help today, but I'll be able to help later this week. And so if you go look at the screencast I put in the channel and then read the source code of some of these other connectors, that'll get you where you would be ready to help someone build one that uses this stuff.